For this one, we're going to use F# free type providers. So you'll need Visual Studio 2012. You can get the web version and install F# if you haven't already. If you can, install it to C Titanic, because I've got hard-coded paths. If you haven't, it's not a problem, just search for C Titanic and change it to what you want. I will come round. If at any point you're having trouble with the task, just put your hand up and I'll give you a hand. Now, don't worry, there's loads of time. I'm going to chat on for about 10 or 15 minutes before we do the first task. So I'm going to introduce machine learning and stuff. For those of you who don't know me already, which is probably many of you, I'm Phil. I help run the Functional Londoners group, which has been going since about 2010. We have over 600 members, which, to put that in perspective, that's, I think, bigger than the .NET user group in London. It's a pretty popular group. It's a pretty popular subject matter. Part of that, I guess, is that there's London and New York have a lot of financial centres. There's a lot of finance and insurance. F# is a really good fit for that. It's also a really good fit for machine learning. So we meet every 2 weeks on the and we alternate between these kind of hands-on sets and talks. Now, what I've found is that the hands-on sets have twice as many people coming to them as the talks. And as your groups, there's something behind all this, I would suggest a good way to get a group started is to do hands-on and actually do programming, rather than just hunting for speakers. So I was particularly happy to come down and do a hands-on session with you. My background, I actually started using F# in 2006, which is a fair old time ago, and I was working in the Machine Learning and Perception group in Microsoft Research in Cambridge, and I met Don, and I thought, this is way less noise than C# for the machine learning work we were doing, and it worked out really well for us. I think it's a really natural fit. It's close to MATLAB, which is what the researchers I was working with used, and we had a lot of initial success. We used F# and created a true skill algorithm, which is used for matchmaking all of the Xbox Live games, which is no small feat. And then we used a similar algorithm, similar ranking algorithm for Ad Center, which is part of the Bing team, and all of the ad prediction that goes on inside Microsoft runs through the F# algorithm we created in 2007. We had an internal Microsoft competition between all the research groups, and our team won, and I got to go to Hawaii and stuff, and Microsoft made an $80 million uplift that year, so it doesn't really get much better than that. We wrote the whole, we had 3 months to do the system. We spent 2.5 months getting the right features, the right data features, and 2 weeks writing the algorithm. Our team was the only team that had stable code that could actually run over the data sets. They did manage to coerce the other ones after about 2 months into working over large data sets, but we still had the best algorithm anyway. So that's a pretty good. So F# has been used in fairly large-scale applications for quite a long time. Quick caveat, my experience is development and applying machine learning, and I'm not a machine learning expert per se, so we're going to focus on that. Also, the fact that we spent all of our time looking for features and less time implementing the algorithm, our experience was that with machine learning, it's about getting good data in, and that's what we're going to focus on today. So that's probably enough about me for now. Let's go into what we're going to do. So the data set we're going to try today is the Titanic data set. So this is a well-known story. There were only about just over half of the passengers on the Titanic survived, and Kaggle have provided us with data on most of those passengers, and we're going to mine over that data and use it to discover, to write a system which will predict whether they live or die. Now, I particularly like this data set because it's very close to actually doing ad prediction. Life or death is the same as would I click on that ad or not, believe it. So, but it is actually, it's sort of, you're looking at the socio-economic status, where they're from, all these kind of things, their age, how much they paid for the fare. So this that we're going to do tonight is easily applicable to an e-commerce site, some sort of shopping site, and you can literally do quite well. We're expecting to get an 80% prediction rate, which is going to be pretty good. I actually took the really simple algorithm that I used here and put it on the Kaggle competition. It put me in the top 100 out of about 2,000 people. So just from this thing. So if you want to be a famous machine learning dude, all you need to do is submit your work today. Kaggle are a data science company based in San Francisco, and they have a number of really interesting data sets, so do go onto their site, have a look. I believe if you were here for Mateus's talk, he was using another one of their samples. Kaggle have actually started using F# internally themselves as well, so that's good. Now on your disks there will be a CSV file. There's actually, I'm just giving you the training set. Once you've used the training set, you could move on to the test set, which Kaggle provide. We're just going to use a subsection of the training set today, and then once you've trained you can try it against a test set. I should probably say something about training and test sets at this point, I guess. So typically you'll have some sort of data with the some sort of training data, label data. So we would, in this case, know for a set of people whether they lived or died. So somebody might manually label them, and then you train over that set, and then you get a much larger body of data, which is what you want to predict on, and then hopefully you'll get results. What you typically will do is hold back some of your labeled data, so you can actually say, does my algorithm work with these other unlabeled pieces? Now, if you don't do that, you will potentially overfit. We'll talk more about that later, and it won't actually be any use on the larger body of data. It will only work on that small set. So examples of that kind of thing happening is stock market. People writing prediction models on a market that only goes up, right? That happened. So they're all really surprised when it goes down because, yeah, it never goes down apparently. If you were to use the name of the guide as your feature, you would get 100% prediction on your training set because you would know, but it isn't going to help you when you run against new data. So you have to be careful of these sort of things. So this is the data itself. Now it's actually quite clean, so Kaggle have done quite a nice job of cleaning it up for you. Usually when any kind of machine learning data mining exercise, you get a bunch of really dirty data and you spend the first few days trying to clean it up, finding all those nulls and other nasties, or thinking you've got a numeric field and then 2 million entries in, it starts to be alpha. You might just be able to make it out. One of the really important features for us on the left there is whether the guy survived or not. We've got name, which we're not going to use. Sex is actually probably quite a good predictor. So you can imagine, potentially, there we are, you're going to throw your wife maybe onto the boat before yourself, or be a gentleman. You may throw your kids on first. Your granddad, you probably say you've had your time. Or he might just get elbowed out of the way more easily. But all sorts of social dynamics might work. Maybe they lock all the working class people in the cabins. I believe that happened. And so you might have a better chance of survival if your socioeconomic status is higher. And we have information can be gathered based on the fare they paid. But there's also oh yes, here it is, P class, 1 being upper class, 2 middle class, 3 dead, working class. Just to think, if you do open that up, if you open up the file in Excel, Excel takes a file lock, and you will not be able to load it into your own program. So when you want to use the script against it, don't forget to close Excel. So I'll bring this slide up while we're doing the first part of the exercise. But here's a kind of description of what each of the fields mean, because it may not be immediately obvious. Another important feature is the port of embarkation. So there's actually picked up people at Cherbourg, then Queenstown in Northern Ireland, and Southampton. And that may be significant. It may affect whereabouts you're on the ship. Maybe being French wasn't a good thing. Who knows? So we're going to start by doing some data analysis. And how many people here have used type providers? A few, cool. So I'll quickly explain those, but probably the more important things, you can get these type providers for most of the common tasks like SQL, JSON, CSV, XML, off NuGet or inside Visual Studio itself, also for OData, those kind of things. And you just plug them into your as references and you're good to go. So it's a really nice lightweight experience. Now, one of the better libraries is written by my good friend Thomas Petracek and another guy called Gustavo who used to work with me, and it's called F#Data, and that has type providers particularly useful for us today for CSV, but also for JSON and XML, and bizarrely the World Bank. But, you know, there you go. Now, with these, you can connect to a data set, like a CSV file, and it will actually give you types and field names without any code generation, right? Which is pretty magical, and just the kind of thing you want for machine learning, because you'll potentially have many disparate data sets that you want to work with, and you don't necessarily want to be typing in weird strings and then getting runtime errors all the time. Not only does it give you the name of the fields, but it also will analyse over the data and work out the types for you. So if it's a decimal field, it will come up decimal if it's string, and so on. So you should be able to actually do that in your editor now. If you have a look at the code, you'll see .sex. You can press dot again, and you'll see a list of the properties come up. The JSON ones particularly cute because you can give it an example piece of JSON, kind of thing you get on a website, as an explanation of how that particular API works. You just pass that to the type provider, it looks over it and actually generate the types for you, so you can then just go and fill it in, which is just makes life so much easier. Probably one of the coolest, two coolest type providers I've seen. One is for Excel, so you can actually get types over Excel on a live Excel running instance. Another one is for Hadoop Hive, and you can get types on that, and nothing else has that capability. So that's going to be fun. So if you can, just let's load those. You want to be moving into Visual Studio now and having a look at the tasks. And the first tasks we're going to have a go at, number one, is some counting, right?
You want something?
So you're going to write some functions, some simple functions that, say, given the passenger sex, we should be able to say whether they're female or not, right? Now, by creating these nice, simple functions that are almost classifiers, we'll be able to write some nice statements and query the data. So once we have our female function, so given a particular passenger, we can define whether it's female, we can then say passengers were female, that will give us all of the female passengers. We can tally up, nice English word, we'll give you a count or a tally of the survivors, the surviving females, right? And that's quite useful to know. And then we can also get a percentage. Now, what's we've already come up against here is quite interesting. If we get something like 60–70% of survivors with female, we know female is a good feature, it's better than a coin flip, right? If we get 50%, it's probably not a great feature because we could just pick randomly and get the same sort of result. What we also need to look at though is the tally, the number that's there. If there's only 2 females on the ship, well, it's not going to be particularly useful for our model, right? Because we could just do a special case for those, right? So whenever you're looking at features, you want to see if it's actually something that's over the whole population of the data. So I'll put it back on here, and if you can tackle task 1, anybody gets stuck, just put your hand up and I'll pop over. Don't be shy.
Is there a route?
There is, yeah. I think there's a reshuffle license.
Yeah, so it's automatically parsing the CSV
Where to get that from?
Oh yes, so you can get, you've got Wi-Fi here, there's some USB sticks, so I'll just get the USB
here, and then this is the operator.
I think there is one over there.
So here we're just taking.
Oh no, that one's good. Great. So it's when you get stressed up, it'll just be more.
So we took the 6 and first 100, we filtered it by.
I was just sort of jumping ahead.
I just like looking at the example.
You can think about that. This is very similar to where and then.
Titanic, as I said.
Okay, so I want to use the emails that we filtered out for giving a percentage. So you never use it.
Oh, I see. Okay, cool. Okay. Yeah, so it's once you've opened the solution Titanic.fsx, I'll So if you've got the solution open, it should look like this, and it's the FSX file, Titanic.fsx. Now, I'll quickly, for those of you who haven't had much experience with F# before, I'll just quickly demonstrate some of the early stuff here. So, to run the code, don't hit F5, that won't do anything. I've set this up in scripting mode, which is what we typically do in machine learning. We start by exploring the data in a scripting style. Once you've highlighted the code, just press Alt-Enter. If you've got ReSharper, you need the latest ReSharper. That works fine with Alt-Enter. If you haven't got the latest version, boo, disable ReSharper. But if anybody's got, there is another way of doing, which is just to right-click and execute an interactive. Okay, so what we'll do now is we'll pick up this piece of code, press Alt-Enter, and that's actually got us all of the passengers you would have seen there, right? So that's all the passenger data available in the scripting environment. And once we've got to that point, well, I might just quickly talk you through this bit. So this is the type provider. We set the CSV provider, and we pass in the path. It needs to be literal. It needs to be a fixed value, a constant value. And then we're going to just create a type. The training row is a passenger type, just to make it obvious. And then we can load, and I'm going to take 600 of the 900 data points for our training set, and we'll hold back the other 300 for testing. And you can see those are the passengers. And as if by magic, there's no code generation or anything. When I press dot, all of the types for that data set are available, all of the properties are there. Okay, and we've actually got, they've got types with them. So embark's a string, but fare is a decimal, right? Now, if there's a null decimal, it will be recorded as a double nan, not a number. Okay, but you'll probably not be doing that one just yet, so very good. Sex is a string, but you'll have to convert it to male, female. There's not much you can do about that. So,
age is a foot. That'd be 33 and a half.
yes, that's pretty crazy, isn't it? There is a guy who's 34 and a half.
Oh, is that?
It kind of makes sense that there's a there may be kids you go with, like, 6 months, 12 months, but 34 and 3/4 doesn't really make that much sense, but that's how it is. So what we're going to do as our first task, so you can see that we had one for female here, passenger sex is female. We want to do one for children under 10. Now, if you think about this, age is not going to be a great feature on its own, because age is dispersed over 0 to 100. So if we try and train on it, how many people are going to be 33 exactly? Not all that many, so it's going to be an awful one to do. But if we were to help our machine learning algorithm by saying this was a child, then that's a good classification. And this is what often actually getting good results from machine learning is more about using your ability as a human to help guide the algorithm. So here I've said child under 10, but you might start tuning it to define a child as under 12. I think in this period, people grew up fairly early, so probably 12 you would be defined as able to fight at that point. And then I've been a bit naughty here. I think life expectancy was about 50 in those days, so unfortunately, instead of enjoying your prime at 50, you may have been first not on the boat. So have a go at those. If any, so give me, put your hand up if you get stuck, and I'll show you how I would do it in a second. You've got 3 minutes. You've got 10 minutes.
I did first class, right?
I think I cast 10 as an integer and then he just floats.
Hi. Good. I was getting bored there.
You want to try to do one little thing? Just kind of, yeah. So there's how much money? Yeah. This is a good question. I don't know what what's happening is we need to do make sure that we so this is how we'll
Was that a winner?
did you
We got something that said 167 children and 74 percent students.
sorry, I probably missed you. So we go to the zip file.
But I thought it was the same thing, 650.
I don't know what the. We might be able to. I don't know how we might be able to run it out. Yeah.
That's true.
Do I have
Yeah, it's still work. So I just opened the other one. Try a sharp one. It's not opening.
I think the first
The file should be
Highlight
lesson project.
If you right click on the
so I
top,
can just
He said drop it in your C drive directly because
Oh,
there's a hard-coded path.
so it won't work on the desktop.
Yes. Sorry, hypervisor.
It won't run on the desktop. The project.
Cut the whole folder.
Yeah, he said take a whole folder.
Just do Visual Studio Express.
Not used to the keyboard.
There's a F sharp, strict 4, F sharp 4, Visual Studio.
There we go.
There's
20 children and 56 59.
oh, sweet. Oh, I see. It's normally yeah, so it's trying to do it as it's happening. Barracks and regiments.
Trick is I was surprised about the typecasting here. The lower 0 there thinks that's an integer and then thinks it's
oh, that's a good one actually.
yeah, like I did the error and I was like,
Alright, so that's
alright, this is an integer there.
So I might just call that one out. One of the things that, if you've come from C sharp, if you pass an integer and it's expecting a float or a decimal, it will implicitly cast it to a float or decimal, which is actually quite an evil operation if you're trying to do maths. In F sharp, you have to explicitly define it. So if it's a float, you have to put 10.0.
Okay, and that's how you define it, is just by putting the 0 on there.
If it's a decimal, you have to put M at the end.
And
it's 4.
yeah.
It's for money. M for money. It's exactly the same thing in C sharp actually, but if you've been relying on the implicit casts, then you're all good. All sorts of really weird maths bugs come out though with implicit casting. So that said, a lot of people don't do any maths during their day-to-day work, so you may not have encountered.
Child.
So has anybody got the survival rate on children?
Yeah. 59.0.
So that's pretty good, isn't it? You're looking good as a child.
No, that's pretty bad.
It's good in the big scheme of things. Yeah, it's not so good. I think if you were a female child, then you'll be really looking a lot better for survival. So that's how your classifier for child would look, and we'll just get this one out.
Oh, I see. So I can just say P and then P.
You want to try one? Actually, let's try to open up like over 3 Yeah. Oh, okay.
So I've got the child one up there if you haven't already got there.
Oh, yeah.
Oh.
So how many people are confused by the pipe operator? Has anybody not seen the pipe operator? I think I'm gonna just explain that. So if you're using like C# or Java, when you want to call something, you would like do function and then maybe passenger. Okay? And then it starts to get interesting when you want us to do another function. So we want to do function, then we want to call another function on the passenger, and it starts to look like this, right? Which I don't think is necessarily a good thing, right? It starts to get quite confusing, right? So that's another function. What F# lets you do is it says you can say I have a passenger and I want to give the passenger to the function. So you give it by piping it to the function. And then we can pipe it onto another function. And that means you can get a nice pipeline. Do this, the result of that pass it to the next function and so forth. And that makes it a lot more readable. Although initially when you don't know the pipe operator it might just be a little bit confusing. But it also means that we can construct almost English language sentences, passengers wear child. I'm pretty happy with that, rather than where brackets passengers brackets child. That would hurt my head. Now, this magical operator, this pipe, is actually, you can define this now inside Visual Studio. I'll try and find some space here. So, literally you could write your own pipe, you can give a different custom operator for it, but it's defined as, you define a custom operator by putting the operator inside brackets. And what we want to do is take a data value, which in functional programming we usually use x, which is nice and terse, and f for a function, and what we do, all the pipe operator does, is it takes f and applies it to x. That's literally how pipe is defined in the standard library. It gives you a taste of just how powerful functional programming can be. So a lot of the things that you would have been explicitly implemented, for example, in C# as language features, are just simple declarations, the operators and so forth. Okay. Anybody got that figure for passengers over 50? Sorry, it was 31. It's not looking good for the over 50s, is it? We could probably tune that to maybe different values, but probably what we want to do is get something that captures a reasonable number of people. So if we go for over 60, there might only be 2 passengers who are over 60 in that time period. And anybody got a number for upper class? I'm going to do upper class now, because you can work out over 50 is just the reverse of children in effect.
Does that matter what your definition is?
It's one? Yeah, it's one.
Upper class?
It's one.
Yeah, 1. Just a little tip for the IntelliSense, okay? So IntelliSense works a little differently in F# to C#. So if at any point you want IntelliSense, so here it's not completing for me, press Control J, okay, and it will come up. Okay, that's, I only found it out by accident. It's pretty handy to know. And because it doesn't say class, it says P class in the data set. That's the one. There we go. Now, anybody surprised by the equals sign? Right, let's quickly do that as well. So we're learning quite a bit about the language at this point. So in F#, equality is kind of more about equality. So in C# you have equals equals. Okay. Now when that's a value type, like an integer, that means are they the same? When it's a reference type, which is pretty much everything else, like a class, it's reference equality. So actually the equals equals operator works differently depending on what type you are, which can be quite surprising at times. So you think, well that class is exactly the same as that one, but it's a different instance, so you get a different result. The reason I think for that default is it's harder to do equality at the structural level, okay, and it's slightly higher performance obviously to do reference equality, because you have to check if the 2 pointers are the same. What we do on our team is we actually define our own equals equals operator, right? Which is just literally, we have A and B, and we say in the framework, it's object, reference, equals A and B. Okay, but what it kind of boils down to, when you use an F-sharp type, right, like a record or a union type, when you compare them, it doesn't compare the instance, it compares the structure, the actual structure of the data. So when you say A equals B, it will be equal if they are equal, right, and not if they were created from. It's not about who created them, it's about whether they are actually equal. Just like values, everything's a value, and actually makes it a lot easier to reason about code. I still get really confused in C# land in the more complex programs. Okay, so that's all you need to do, upper, and you just follow the same thing through. Let's do that, just so we can see how the upper class live. So the upper class had similar kind of survival rate to females, so seemed to be a good place to be. Probably being upper class female and a child would be the winning ticket. We'll look at that later. So I'm hoping you might have appreciated the type providers at this point. I mean, it's just such a nice experience for you. Typically, people doing machine learning will use something like F# or Python or MATLAB. With Python, MATLAB, maybe Clojure, you've got none of this nice type information. So you're just constantly switching between the data description and back again, trying to work it out. Whereas here we can just focus on working on actually the data itself. Also, we're building up kind of like a DSL, a kind of like vocabulary over the data. So we have a function called child and a function called female and a function called upper. And later we'll be able to compose those functions to ask queries of our data set. So far, is everybody happy for us to move on now? Anybody stuck? Put up your hand or forever hold your thing. Okay, so we've only been looking at sort of binary values so far, true or false. Okay, but some of our data has multiple points. So the embarkation point, if you remember, was Cherbourg, Queenstown in Belfast, in Northern Ireland, and Southampton in the UK, and in England. So what would be nice is to actually get percentage values over 3 or more values. What I've got here is a survival rate based on a criteria. Okay, so the criteria could result, we could return 12 things, 2 things, and we want to get percentage values out. What we're going to do is just use F-sharp's built-in functionality. We could do similar things in LINQ, but we just wouldn't have this nice piping format. So, or in IntelliSense, or type inference. So, we'll take the passengers and we'll group by the criteria. Right? So if we imagine we've got Southampton, Cherbourg, so on, then we'll be grouping, you'll get all of the passengers that were in Cherbourg, a group of all of the passengers that were in Southampton and so on. That's how the data will look at this point. And then that means we've got a key and all of the matching pieces. So we're going to map, which is the same as select in C#. we're going to map from the key and the matching pieces, and we're going to keep the key, so we can see that, and we're going to map the matching passengers to get the percentage of them who survived. So then we should be able to see from that, Cherbourg, N% survived, Southampton, N% survived. And so we can just pipe different features into this and see the results. So let's give that a try. Another kind of handy F-sharp feature, if you get a bit confused over what's going on, you can get even more confused by hovering over it. But actually what we're saying here is we're going to pass in a criteria, okay, and a criteria returns an alpha, anything, okay? That's the thing we're going to group on. So it's expecting a function that takes a passenger and returns anything, and it will return us an array with the anything and a percentage, right? So the alpha and the float, and the square brackets means array. So that hover over is actually awesome. If you hover over a class, it will actually tell you everything about that class. I really miss that when I'm in C# land. So I haven't used any classes here, but if you pop in on one, you'll see. So let's drop this, Alt Enter. So we had that, we've created our function, and we can see embarked S gives us 34%. Southampton's looking really bad. So getting on in England is not a good survival choice. The French actually seem to be doing remarkably well. They must have been first to the boats. And the Irish have done well as well. So probably what we can say is these are actually quite close to 50%, which is quite close to a coin flip. Not such a great feature, but you could say if you didn't get on at Southampton, then your chances were pretty good. Okay, so let's pop into the task. So we've done it via embarkation point by passing it a function that takes a passenger and returns the embarkation value. You need to do the same thing for the passenger class. So just quickly explain this. F-sharp's a functional language, and F-sharp, the F in F-sharp stands for fun, and so fun is a keyword in F-sharp.
Awesome.
And this means...
Please tell me that's the actual design decision.
It is the design decision, it's there. Yep. So what we're saying is this is a function, a lambda function, an anonymous function. It takes a p and returns that. So it's the same as your equals greater than in C#. The main kind of difference here is that the type inference just works in F# because it's across the whole program. In C#, you don't really get a lot of type inference comparison. Okay, so 5 minutes on this one. Oh, the second one is a little bit harder, so don't be surprised if you move from not thinking to thinking at that point. Yes, yeah. So I might have to introduce some more syntax at that point. But that's what we're doing. We'll get all of the syntax out tonight.
So we would have to take two separate things. Go ahead. So the range is what we would have to test.
sound like the lamest question ever. How do you get the F-sharp interactive bottom section in MSVS? Because I only get output, I don't get.
Oh, okay. Yeah, no, good question.
So I can't alt enter and F5 doesn't do anything. I haven't used MSVS in like 10 years.
Okay, well, you've got multiple problems, so yeah, I'm going to come around. It looks like you may have not unblocked the thing. Did you drop the things?
Yes.
Yeah, you've got a blockage problem. So if we go to the Titanic folder, do you put on C?
Yeah.
In this case, yes. So
And
yes.
just go to the lib folder.
Feeding into imaginary.
So basically we have 7 unblocked, so we just need to unblock these pages.
Yeah, just test, it's not binary, so we can test it.
Oh, okay. You meant unblock the DLLs.
Well, if you don't unblock the zip, then you...
Well, I didn't even get the option to unblock the zip. So I was like, I guess it's not.
Yeah, sometimes you get double whammy, you have to unblock the zip and unblock
Okay,
afterwards.
I didn't get it either.
It just depends on... I haven't worked it out yet, there's some machines that really...
So we could
I guess corporate machines might be more... Anyway, this usually fixes it. So all we need to do is find Visual Studio.
Right, and it automatically does it. So basically, so survival rate, right? So here's our criteria. I guess we can find our criteria. It's a survival rate. So
It's like, oh, it's not coming up.
take this through that. We'll fill that out.
Okay, now we should
So the problem with the next one is
tell us.
I'm gonna say
now
greater
we've
than
just
10
been
is a job, and less than greater than 50.
like some.
Oh wait, greater than 10 and less than 10.
Right, now in this case, we have to we actually have several different groups that are already done. So this is
I can just tag for something else.
Yeah, let's give it a quick shot. It's looking a lot healthier this time.
okay, so we've already worked out who's the senior right here, right?
There you go.
So that
What, you just hit all done on that one?
Yeah.
50.
Okay,
So
cool.
Let's put some real, let's put the data in and see what comes out.
it goes down to an array.
So that should give us a bunch of passengers.
Oh, so you...
You have to highlight first.
Awesome, okay.
Yeah, like
That's crazy.
It is really cool. I mean, to do this, if you imagine to do this with like C# and you'd have to keep rewriting your program, recompiling.
I usually do Linux stuff, so this is magic.
Cool.
because
So
yeah, we want
we can make this
we've
one.
done senior, we've done we want survival, survival rate, so we're seniors. So,
I mean, this is not anywhere to do. Because it's just there on the screen. So
I'm guessing. This works.
there's probably a better way to do it.
That's really close to it. I did something right. I think we got
So you could just suppose each of the ones that the so each of these
Has anybody finished? Cool. So we've still got quite a bit to go through because we haven't got as far as the machine learning algorithm. So what I'm going to do is I'm going to do this code here if you want to just follow along. If you feel like you're nearly there, just keep going. So to do the passenger class, this was pretty much like the last one. So if I use the Control J, remember, that gives me completion. So I'm not doing very well in front of an audience of typing. Not normally this bad. And for the class, it's the P class. And that's all there is to it. Now we can have a look at the survival rate by class. So third class, really low survival rate, upper class 60%, middle class pretty much coin flip territory. It's not really a great predictor, but not being lower class seems to be a good place to be. So let's do the next one. This one is a bit more complex because if you haven't done F# before, you're going to have to probably deal with ifs and thens, which are a little bit different. So take the survival rate again. This time we're going to take a function. We've got the passenger, and we've already got some functions. So if we say if it's a child, right? Now what I'm going to do something here is something that you may feel icky, but we're in an interactive environment, and we're just trying to get data out. So I'm actually just going to give that a string. So I'm going to just say that was a child. Now we can say else if, but we can shorten that to elif in F#. And we've got, I didn't actually write the function, I have to go and write it now.
For adults.
Yeah, well, we can do, we can infer that if they're not over 50, then they're good. So they're an adult, they're not one or the other. So, so yeah, you should have already, you shouldn't have cheated like me and not done that. So we can put that in over 50, and then otherwise it's going to be return adult, and that's all there is to it. Yeah. You could also label these as like 3, 2, 1 or something like that. But because we just want to have a look on the output, string's fine. So if I run that, oh, you need to do what I haven't done, which is to push the over 50 function into the interactive window. Let's just do that. And now we can push that function in. It's quite awkward when your screen gets all inflated like this. But this is quite a good stat. So adults, not great survival rate. Over 50 is even worse. Children, looking better than a coin flip. So the next part we're going to look at is scoring, right? So we've got our test passengers. So for our test, so we've done our training set, okay? And for our test set, we can. The training set was the first 600 passengers. The test set, what we're going to test our ideas out against, is the passengers beyond the 600. Okay, so we can do that by just saying skip the first 600. Right, it's quite handy. And then we'll have those ones. And then we're going to have a score function. The score function will take your function, okay, which will, given a passenger, return true or false, lived or died. okay? And it will give your score based on running against a test set, okay? So it'll do that, taking the test passengers and getting the percentage by applying your function and testing that against whether they survived or not, right? So with our score function, we can now write our own classifiers and see how well they did. So let's push our score function in. We're calling it the score because obviously this is a competition data set. So my simplest classifier would be to say nobody survived, right? So everybody died, right? And let's see what kind of score we get with that. So given a passenger, it always says that they're dead, right? It's a fairly pessimistic classifier. And now if we score that, saying everybody died gives us a 63% prediction rate. That's pretty good, actually. Now, having worked in a machine learning lab for 3 years, every month or so, we get somebody who's doing a PhD at Cambridge or Oxford over to present on their machine learning work. One of the things that the researchers at the lab did, there was 3 put-downs, and I'll give you all 3 of them as we go. But one of them was, how does your algorithm do against the average, right? So typically, people will spend 2 or 3 years of their life coming up with a fantastic, clever, complex algorithm that gives worse prediction than predicting the average, right? And this happens. This is over half of the people I've seen. So the researchers had these things off pat, and you could see people's lives in ruin as they did this. But so you don't have to suffer that, forget all of the clever maths bit, find the average over the data set. If you're not doing better than the average, you're doing it wrong, or you're applying the wrong algorithm. This one fact alone makes you probably better than 50% professional machine learning experts. So, but unfortunately, that when you're going deep and you're trying to do an advanced neural network system, you're more focused on trying to get that working rather than actually trying to get a good result on a particular data set. In the real world, we want to get a good result, not a great fancy paper and lots of maths on it. So, we've got our score function. Let's say you're going to use embarkation point as your potential thing. Let's see if we can do better than average with the embarkation point for predicting. So, create a function that you can pass in and which will return true or false and score it. It's a pretty nice place to be. All we need to do is score, right? So you could have also done that as you could write these as a lambda as well. So you could just write that as that, yeah? If you want 100%, right, but that's cheating. On the actual test set, which is why we're using a section of it, the actual test set, you don't get the labels. Okay, so there's 5 minutes for task A, and then I'll come back and I'll work with you on it in 5 minutes. Please put up your hand if you're stuck in any way.
I think I'm not.
You were right. Which drives it?
I know, it's all happy now. Looks good. Yeah. So, just to get going, have you pushed any into F-sharp and strategies?
I have. Result.
Okay, so let's go now to the top. Oh yeah, so just
You'll find like 100%.
Right.
just throw that. Just throw that in, that's fine.
Yeah.
Throw it in, just pull that.
64.
And then just, just scroll down, keep scrolling, and code it.
Just female. Female.
Yeah, it's a pretty awesome experience. It's really interactive and
Yeah, sorry, so we're trying to show that's not reading this. We're trying to construct a function that's for
so now we've got number of females closed is down to 67, 600, and 78
I was trying to find
well, if it's not showing red screen.
yeah, and then we're trying to get the 8%. If I understood what this was doing practice. Right, so this is just going to be so this is our gas piece.
So if you're
so if we were having an additional 7 reports because we were requiring all of them for survival.
actually
So we should do for
which is their JavaScript.
We should count how long.
It's this actually the manual for the I actually find things that
So if you go to that's one.
just have it just
well, it was only 14 out of 50, so it was the same. Like we
yeah.
So
How we do that is for the like
yeah, so we can't really infer that much because
right. This is very binary. They might
well, it's possible that they were on the boat as well. Didn't survive.
That's true too.
I imagine the boat journey wasn't going to be 100% survival.
How many days at sea were they?
That's true.
Like you have to mark
But it's still going to get,
So
by the time we're done,
is if that
quite remarkably good. Much better than average.
so there's
Cheers.
Is this,
Oh,
so I was following the instructions, oops, I lost it, right.
oh, cool, using Tsunami.
Yeah, well, I'm just poking around.
Oh, you play with my balls.
Yeah, here we go. Here we go. So I've just followed the instructions here. I'm running a new monogame project in Xamarin Studio.
Cool.
And I got to this point.
Awesome.
Does this mean I got it set up correct?
You're a man.
Okay. So obviously this is just a shell. It's not interactive. I have to add a logic and so forth. Okay, thank you very much. And now, should I be able to push that over to my class? Just it's not functional.
I guess so. I haven't got Google Glass. Yeah. I've got another sample as well, which I did this generative art class. I have this like really tight sample, which doesn't use monogame, just uses
That draws on campuses?
it draws little bubbles on the screen. So
Is that, but that's not one of your blogs?
Oh, you don't need
I
this.
see a link, there's a link to,
You don't need this.
yeah, it's
I'll work
just
on
in
that.
case.
I'll work on that
If that
next.
doesn't work, maybe try that one.
Okay.
See how it goes.
No, I think you just get this.
I have no idea.
Right, because this is, because you just have one expression.
TV's about to turn off.
What do I need to do? That.
That
Okay.
you could also.
Yeah, so so that the bubble sample.
Okay, so when you say vanilla, what do you mean by that? Is this like vanilla?
No, it's no monogame, it's just like that 20 lines of code, so it's easy.
Yeah, I'm trying to keep it simpler.
Because monogame's probably the best thing for high performance.
Well, yeah, I don't need high performance, I just need to get something.
Maybe have a look at the bubble sample, because
Now, will
that's...
that run on, I don't even need to have set up the monitoring stuff for that to work.
No, it just works.
And do I just like create a solution and then throw that into a file and run?
With the bubble sample, yeah, you literally can do it on the Mac side.
Right.
No,
So,
pressing
So
down.
create a solution, create a file, dump that code in.
Dump code in, press F5, done. Yeah, happy experience, yeah.
That's what it is. So it's.
I'll give us a chance,
This
yeah.
This is.
Doesn't, but...
Make sure that she just.
And then see if it's converging to the reference. Yeah, pretty much. I mean, simple way to approach is if, so this is your inbox classifier, you have to do better. So one thing you can do is if this returns false, so that because it goes back here, check
So, just for the embarkation one, like we said before, not getting on at Southampton was probably a good place. So, in effect, if you're not English, because the people who got on at Northern Ireland are Irish, you would, not being English is a fairly good chance of survival. So we've got 63% on that, which is slightly better than saying everybody died, but still not that great. So the next task is to construct a function where you can get a score of over 80%. Now that's being a little bit optimistic. If you can get close to 80%, that would be cool. But you're going to have to take on multiple features to do that. Right? 79, yeah, that's about as good as you'll get until you go and explore features outside of what we've already looked at. But when you're doing that, what you'll probably have seen is it starts to get a bit more hectic. You have to start thinking a lot in order to do it. And it feels like it's something that maybe the computer could do for you. And that's where I'm going to go to slides in a minute. So I'll start. Has everybody got the not English one? It's up there. Well, let's have a go at the scoring. I'll start you off. See how we go from there. Okay, so let's write a good score function. This is an optimistic function. So we'll take the person, if they were a child, right, or they were upper, maybe that would work. Let's have a look. So we just got to play around a bit. So that's given me 75%. That's pretty happy. Let's see if we throw in all they were female. Cool, winning, right? Now what you might also want to do is like go, if they were a child and they were upper class, or they were female, and so on, yeah? But you're starting to get into, as the number, that didn't work. So as the number of parameters you're trying to play with, this and this, or this and that, it starts to get quite, it's parametric in complexity. You've got more and more different things as you bring in more parameters. So have a play with this for a few more minutes, but hopefully what the idea of this part is to give you a feeling of, oh my, there must be some way to automate that, and that's what I'm going to show you. That's what we're going to do, a machine learning algorithm. So up to this point, all we've been doing is really important thing behind machine learning, which is finding a good set of features to work with, but then we do the scoring. When we were doing the ad prediction for Microsoft, there were actually a few really awesome features. One of them was the IP address, right? So there are a lot of spam bots who are trying to, there are groups of people actually clicking on ads of competitors, companies, and not clicking through in order to cost those other people money, right? People pay for that. So there's groups of people in the East who do that, right? And so by looking at the IP address range, those are basically fraudulent clicks. So we can, in effect, by looking, almost wiping out entire parts of countries, remove fraudulent clicks. Another super feature was the browser. Right, so every time you send a click, you send up a user agent, which says something like, "I'm IE, I'm running on Windows, maybe XP or Linux or Mac," and so we wrote a classifier for the user agent, which made it into a nice set, a bit like we do with age, and so we could say whether they were literally coming from Mac, PC, or Windows or Linux or other. And we could also say whether they were coming from an old browser or a new browser. Now it turns out that people on old browsers on Linux don't buy anything, right? People on Macs with new browsers buy everything, right? So you can work out where you want to be targeting your ads. That was one of the super features. So, you know, this is really what gets you the good results, is doing this background research and giving your algorithm a fighting chance against the data.
rate on it, so you wait each one based on this. Let's try it.
Okay, so, oh, okay.
So here, let's say one area is separated. So each of these features can be weighted from one to the other. So let's do this case here. So let's say female was really pretty good. So let's say female child was good to first class. Okay. This was very recent. Let's try that. Human is so we have four features. And that's
just as a little sidetrack, there's some really good F# cheat sheets. So if you're new to the syntax, the cheat sheet's a really good way. Just having to go through. If you just search cheat sheet. So I'm going to spend another 10 minutes talking on for a bit, just to introduce the next part. So far what we've done is we've built a scorer that's giving us 80%. We've done that by hand. Okay, and I'll just recap what we did to do that. We've looked at F# type providers. That gave us nice typed access. We've done counting, right? We've created percentages. These are all off really simple functions being written in 1 or 2 lines, humanly readable. And we've done all of this inside the interactive window. We can find out survival rates over not only Boolean features but over a range of values. And we've got a score function, so we can given a function, we can get a very good, quick, easy way of finding out what the value was. So this function gives you, I think, over 80%. So if it was child or female and not lower class, then you're good to go.
Can I ask a question?
Sure.
Actually, if we remove upper class, it doesn't matter. I mean, that's
right.
Should we include this, or?
I think some of the features will cancel each other out, right? Now, but what we found, I think, by doing the manual creation, when we do it over just a single feature, we can pretty much think and reason about it. But as the features get divided up and we're trying to apply them together, it becomes a lot more unwieldy and actually too much work, right? Depending on, if we only needed to get 80% prediction rate, then that would be fine. We could just say that's enough. There you go, boss. There's your algorithm, right? But if we wanted to go for a higher rate, there's a value associated with it, then we're going to have to go into something, hopefully, that can automate the process of going and searching over the feature space and finding the best combinations to give us the result. And that's what we're going to look at now, which is machine learning. Hooray! So we've done, it's a bit like the competition I was describing, we've done 2/3 of the evening has been about finding the features, and the last third is going to be about applying a machine learning algorithm. So I've actually pre-prepared machine learning algorithm for you this time, so all you need to do is call it, and that's typically what you would do. Most of these algorithms are already pre-written, and or you would spend like weeks, labour of love, creating your own one. It's not something particularly good for a little 2-hour session. So the algorithm we're going to look at is decision trees. Now, decision tree is pretty much what we've been trying to build by hand, right? So if it's this, or it's that, and it's this, then it's alive or dead, and you're kind of building up over that. So we want something to do that automatically. Now, in effect, we're going to build a machine like the 20-question machine. So the 20-question machine is a bit like the game Animal, Mineral, Vegetable. So somebody thinks of some random thing, maybe a person or an object, and in theory, you should be able to guess that within about 20 guesses, maybe less, right? So 2 to the power of 20 would be 1,000,000. So you should be able to find something in a set of 1,000,000. Now, to do that though, if I were to say, you think of something, and I say Roger Daltrey, that's not you say yes or no. I haven't really got the space down. What I need to say, animal, and you say yes or no, and I say mineral, yes or no, I'm dividing the space down, and then I can work my way down, and then maybe person, and then, all right, I'm on person, and then I'll be able to find Roger Daltrey. I might say musician, you know, we start to break the space down, or male, female, that would be a good set. So what we're going to do with a decision tree is have some sort of automatic way of, at each point, finding the question that will give us the most amount of information after we've asked it, right? So animal, minerals giving us a lot more information than is Roger Daltrey. So there's a value that gives you whether you've got more or less information, the Shannon entropy, which we can apply, which is pre-written for you, and we'll use that. And what we're going to say is go over every single feature and say, if we ask this question, will we have more information, right? And the one that gives us the most information, if we ask it, we choose that one, right? Then we go over the remaining data and the split data, and we ask the question again, which one's going to give us the most information, until we get to the point where it's not worth asking the question anymore, because we know the answer, right? And by doing that, we have an automatic way, given any set of values, find me the best decision tree. So this is actually really applicable to real-world tasks. We could write some sort of prediction system with this. This is used a lot in production systems. There is a variant of this, which we're not going to cover tonight in any depth, which is random forests, which is a variant of decision trees with a random element. And I'll have a link to that on the end of the slides. But if you can apply this baby, all you need to do, instead of calling decision tree, call random forests, and it will give you a decision tree. So, in effect, a decision tree looks like this. So let's say asking male female would be the best, gives us the most information. That would be the first question we ask. Male, no. Survival, yes. So that's a fairly early out there, right? No point asking any more questions. Is age over 9 dead? Right, so you're not a child, you're male, and you're not a child, you're dead. And so on. And then there are some other features like number of siblings. Right, so it turns out that if you had a number of, if you were in a large family, your survival rate is probably quite high, because those families would have worked together to get their whole family onto the boat. Whereas if you're an individual, you're less chance of getting on because you're really nomads. So, in effect, we're going to build one of those. Now, the nice thing about decision trees is that once we've actually generated the tree, we've got very quick traversal, right? So we just have to follow it to do the prediction. So we've got a really fast classifier. What you can actually do, if you want even fast classification, so you can take that tree and generate it as code, right? And literally you're full speed, you know, you can't go any faster than that. So, actually I used a similar system. I was working on a video game called Project Gotham Racing on Xbox, Project Gotham Racing 3, and we applied a reinforcement learning algorithm. A reinforcement learning algorithm, very, very complicated, but actually the end result of it spat out a decision tree, which was awesome, because then we literally, it was like, the decision tree would go, oh, on this point in the road, going this velocity, turn a bit, or accelerate, or and so on. And so we could serialize out the decision tree and put that into the game. We actually had the learning online. So the learning was learning as you drove. I had it set up, and Bill Gates played this game, this particular system, which was nice. I missed him, but he enjoyed it apparently. So you drove a lap, and it would learn online from your mistakes and your successes. So we'd give it a feedback function of whether you're doing well or not. Because it's reinforcement learning, it learns from bad behaviour and good behaviour. So even if you crashed into all the walls, it would learn a lot about not crashing into walls. And it would always drive a faster lap than the human after learning off one lap, which is pretty cool. And then it would continue to get faster. It would learn off its own mistakes from there. So these things are amazing.
Did you reclassify the tree every time that happened, or?
Yes, it was rejigging the tree constantly online.
If you have like a large data set, isn't it pretty expensive though to do the
It was
initial iterative classification like that?
Yeah, it was pretty heavy. It was all written in C.
It's Microsoft.
I know. So it's me and this guy. He now works for some government agency on black helicopters or whatever.
And computer data centers in Utah.
You get the general gist. Very smart guy. Anyway, moving on. So yeah, but these decision trees are a good endpoint, and you have a number of different algorithms which may lead to a decision tree. So I won't dwell on this particular one, but for the code you're going to use, there's a book called Machine Learning in Action, and it's got a load of samples in Python, and I just ported their sample from Python to F#. You see Python looks pretty much the same as F#. You don't have like many type annotation. Obviously the F# version is half the size. I guess some of the differences is Python is interpreted and dynamic. F# is using a much cooler technology, type inference. So you get the same lightweightness, but you get the types. Now what that means in effect is you get to press dot and values come up, the list of things that you can do. That's pretty useful. Also, you find out at compile time whether it's going to go wrong. You get as you push it into the interactive, you get little red squiggles rather than pop after you've run it for 9 hours. You find out before you run it for 9 hours. The other difference is that because we're statically compiled, we're actually going down to IL code, which is then just-in-time compiled into assembler. You're actually getting similar, if not better, speeds than C++. Right? And I say actually with some confidence, because you're focusing on the algorithm, typically you'll end up with a faster solution if you use C++. My friend John Harrop just replaced a business engine that's being used heavily in an insurance company called Aviva, the largest one in Europe, and you've got a 10 times performance increase over the C++. Typically, you get 100 times performance increase over Python. So you get shorter code, correctness, speed, and if you're familiar with Python, you're good. That said, speed isn't everything. Maybe it's useful to just use the best tool for the job. Python can be pretty good. There's some nice algorithms already written in Python, so you might just want to try those out. If you do, there's a really nice plugin for Visual Studio for Python, PVTS, just search that, and it gives you full syntax coloring and stuff, and a console like F# Interactive. I found it pretty useful because I could just look at the hideous Python code and then go, what the hell does that do? And then I run it to actually find out what it does, and then I can test that my nice typed code was giving the same result. I mean, one of the things that F# trying to do is not try and be the one true language. It's trying to be useful for a particular set of problems and interop with other languages. So we could interop with IronPython. There's another machine learning statistical language called R. Anybody here used R? R's great. It's got a huge number of really nice algorithms written by the community which are free. There's a type provider, like we have a CSV type providers, there's a type provider to the R language, and you can actually invoke functions on R. So you can create the data set in F# and then call R and ask it to do an algorithm or even plot a chart for you. And then you can bring the data back out of R and then maybe store it to SQL or run some other algorithms, maybe go and call Python, right? And so in effect you could think of F# as your cool, nice tool, and also your tool for orchestrating a bunch of a bunch of different languages together. And I think as we, number of languages isn't decreasing, in machine learning it's kind of increasing. So in a way you want a way of orchestrating and using the best tools. So in order to call our machine learning algorithm, I didn't completely turn the system into idiomatic F# niceness. There's still a bit of that Python hanging around. So you have to write, you have to provide an array which is the labels. Right? So I've managed to construct one which is instead of machine learning class, it's our sex class. And that's the point of this whole thing. It's actually just like 2 hours. So, and then you provide another one, which is to give features, which will provide those 2 features. And so you can, the tricky thing here, it isn't nicely typed. So if you want to add another thing, if you want to throw in the embarkation point, then you would have to put embarked here, you have to give it a label, and you have to put in embarked here. Now, nice thing with a decision tree, it isn't just binary, you can have multiple things, right? So a tree could go 3, 5, 10 ways. Typically though, you'll get about that prediction if it isn't too wide. Like we were saying before, if we gave it age on its own without classifying, then you wouldn't get anything useful from it. We use this craziness to push that together, and then we just say create a tree. That will return a decision tree, and we can pass that decision tree into our scoring. I might just explain this craziness now. So, where you might do a select function, right, which is a map, select in C# map. So, Microsoft tried to kind of make LINQ look a little bit more like SQL. But the map function is something that's been around in functional programming since the 60s, and it's been called map since then, so it's a bit of a travesty. Anyway, what this is we're saying for all the passengers, map them, so this is just a mapping operation. This will return an array of this, right? So I could do, let me just hit the code. These things are awesome. You've got these in languages like Erlang, Miranda, and Haskell as well. So most functional languages have got this capability. So let's say I wanted to get the squares of 1 to 9. As an array, I can say for 1 to 9. So we can actually have a range of values by just doing ... and these square brackets are for with the pipes are for arrays. The reason for that is that list is already taken with the square bracket. So to do arrays, we do like thus. And if I and that magically just created the squares there. So it's a really nice, cute syntax for mapping. It's a much shorter syntax than the array document. And not many people know about it. Let me go back. So there's another thing that may not be immediately obvious. So people have used C# IEnumerable yields. So that's pretty much everywhere, everyone. So in effect, you can create something that yields different values through. So we've got the yield here. If you wanted to yield another sequence from inside of that, you'd have to do for each item in that sequence, yield that value, which is a bit boring. So what F# does is it has a yield bang, which means yield many. Which is just yield all of them for you, and you don't have to do it for them. Right? And ironically, JavaScript 6 has that functionality too. It's going to be called yield star, which actually I prefer, because it's like multiply. Yeah. JavaScript for the win, huh? So,
That's a first.
Actually, JavaScript's starting to have some applicability in machine learning as well, because it's quite nice and easy to poke into places, because it can just be evaluated. A friend of mine, Greg Young, has anybody heard of Greg Young? There's one. Okay, so Greg Young is famous for being a loudmouth Canadian who is very nice, and he does, he kind of almost coined the term CQRS, which can be boiled down to command query responsibility separation. So in effect, separating your queries, your reads from your writes, which is actually a pretty good strategy. And he's created something called event store, which lets you store commands or messages in a sequential rate and then query over them. And he's using F# as well, but he's also got a query interface in JavaScript too. But yeah, actually he's going really big into F#. He's going to be doing a talk at our next meet. So. Oh, and he's using Mono as well, all on the server side. So that's slightly digressing. So before I get on to the classification part, we mentioned this slightly before, this term overfitting. Okay, so the overfitting idea is, like the stock market example, only looking at data set in a small space and being really good at predicting what you know, but not very good at predicting things outside of that. Okay, so not holding back some of your data to test against, that sort of thing. That's another one of the put downs, by the way. So decision trees are actually, by their own kind of design, they do tend to overfit because we're not putting any variance on the values, right? So to get a good decision tree, you're going to have to give it quite a lot of data. And so if you are having a problem with overfitting, then switch to a random forest, which is just in effect dropping a different algorithm in with the same interface. And I'll give you a link to a random forest implementation in F# at the end. So once we've got our decision tree, we're able to use the decision tree to classify. So the decision tree will come out will either be a branch is of multiple places. I've only got 2 hands, so chopping it up, or a leaf, which in this case would be true or false, survive or not. With the actual decision tree, you could return any number. You could have like 3 or 4 things you could return. It could be male, female, or unknown. Who knows? You know. So this just recurses over until it finds a leaf and returns the value. So that's what we do. You could use this thing as you could use the classifier to actually instead generate some code and then call the code. But this is good for us. So this is our next task and our last task tonight. We'll see how good we can get our classifier. So let's just switch back into the code. So, does anybody have any questions on what I've just discussed? Cool. You can always ask me later. So, I guess the thing to do would be to just run this, right? Let's find out what happens. So, if we drop in down to here, just take the tree, okay? And have a look at that. That's actually generated a tree based on sets in class. Okay, so the first branch would be on sets. It's decided that's the best place. Looks like we're winning, right? And this is the nice thing here is we can actually visualize the tree that's generated in F# Interactive. As we build it deeper, we'll see that, oh my god, I didn't want to write that. You know, it's going to get nasty. So if it was male, it's going to check. If it was, well, actually they're all false. Male is just dead. Right? In this particular classifier, because it doesn't have a lot more information. It's male class. And female's all true on this one. So this particular algorithm isn't like optimizing it back. So once we've got our tree, we can write a test function. So a test function, given a passenger, it will try and classify based on the tree and the features. And if we get some value out of the classifier, then we'll return that value. If we don't get anything out of the classifier, then we'll return the mode. Remember the mode? The average? Right? That's a pretty good policy. If we can't predict it, we'll go with the average. You're winning. Alright, remember? Now, important. Now, the reason why we have to do this, you might think, well, haven't we got the whole space? Well, we haven't, because we're only training against the set of data that we know. Right? Now, it's quite highly likely that new values that we haven't ever seen before are going to come up. Let's imagine we went over 1 gig of data, and then we get given 10 terabytes of data. More than likely there's going to be things that our decision tree hasn't got, and for those we need to pick the mode. Okay. So if we drop that in, then we've got 77% of that classifier, which is nice. So your task is to tweak these values, put in different features. Now don't forget, you need to put in the label every time you add a new classifier. Right? But so here, instead of putting p.age, we might put in child. Yeah, so that would be a return a true false value back for it. So I would do this. But yeah, the idea, so that has created, you can see there's some more variance now. There is actually making different decisions at different points now. We'll just score that. Notice how we're able to use the same score function that we did for our manual classifier as for this one, which is nice. Oops. So that's taken us up to 78%. So 10 minutes. Let's see if you can win the Kaggle competition. I'll show you what the scoreboard is looking like while you're doing that.
How often have you tested how often typical algorithms you have in production fall back on your mode?
Yes. Oh, this story that I shouldn't tell.
Let's just say it was for Red Hat. The Red Hat's the company.
Yeah, let's say it was Red Hat. Right. So imagine. So when you're doing machine learning for ad agency, what you actually do is you have like two sides to it. It's exploration and exploitation. Okay, so if we have known data, so we know for a particular ad, we learn what the click-through rate is, and combined with what we know about the person, we can combine the two and give a really good thing. But new ads come along, right? So we have to have an exploration point where we randomly throw ads in, right? And said ad agency set the exploration rate at 100% and didn't realise for about 6 months until we were putting in our algorithm to test against theirs, and went, oh, by the way, your results are off. Are you sure you've got your 90 plays turned on?
I've set the exploration to degrade over time. So like on day one, I'll start at 100% so you can explore. This is usually with very, very large sets like you guys use. So you can explore a very large set very quickly. Now it pisses some people off, but you explore a lot. And time-wise, very, very quickly.
Right, and ramp down.
Yeah.
We pre-learn the exploration rate is
This is usually I have no data and I'm getting it right now, and it's just a crappy multi-arm bandit implementation. Just let it run.
I got that to work.
awesome.
Yeah, sure. You tried one of those things yet? Put it on. Can you read the smallest one? Good. Put it on. Just like stuff. The question I have for you, and you're on the internet now, so let's push the You saw what I was doing. Just tap aside. Another way to and move around like that. But now, okay, class. Google.
That's not what we do.
How old is Barack Obama?
Notice that those are just the actual features in the Boolean value.
And then if you tap it, you can sometimes surf the web and things like that.
That's pretty cool.
The question I have is, okay, and I got to this point using another example from someplace or other. Right down here, I should be able to override something like onDraw, but there is no onDraw.
Yeah.
So I need to override that so that every time things change or something changes someplace, either in the environment or time-wise. Okay, well maybe it is. I'm just gonna. Is this the same as base?
Oh, you can call it.
No, it doesn't work out. This or base? Whatever.
Oh no, well sorry, base is special actually. Base is the.
Because in the other example,
This-
it was
this
base
is-
and base.
This isn't the keyword. It's just whatever.
Oh, I see.
Well, because the problem is, what they pay.
It's going to be on.
Wow.
Yeah, I would think, but none of them seem to apply.
Well, that's,
Yeah, with this algorithm.
Everyone else is doing it.
99.5.
Nice.
I haven't used this
Oh,
one.
wait, we just sorted on.
I thought it kicks the line's ass.
So expand this motion.
Yeah.
Expand this motion.
So this takes,
Well, I was blown away by how easy it was to get
this is just.
being off to the chance.
Okay, well, I don't want to abuse the.
It's got to be in there.
So it's got to be in there somewhere. All right, so maybe just call it something else.
I'm going to meet Miguel, who owns this stuff.
So can I DM you or something? You can DM me the magic.
If I haven't sent it to you by end of Wednesday,
All right.
then remind me.
Well, thank you very much.
I'll get into
oh, like.
But it should be.
Because I thought those other ones you did, were those using that mono game? Or?
Yeah, my game's good. I'm not familiar with this.
Yeah. So the mono game I should be able to deploy that as well.
I don't see why not. Yeah.
Okay. So I should be able to. I tried to deploy the blue background template, but it didn't have one. But
Well, it could be.
it's all very.
It's compatible with some.
Where this is.
It's definitely. I wonder if it's an event. Could just be.
Yeah, go like.
Just get so much to do.
I mean, eventually you could use it like, right now, like,
So, how about we just,
well,
let's just try.
$50 and less than.
So maybe inside, maybe inside the scope of.
Yeah. So
So try it. See if there's
rather
one.
than an on, it's like an event maybe. So like this type.
So there couldn't be an on draw inside here.
Usually, I would say
Look at the ons.
more data.
Would they be the same? A lot of the time, smart enough.
A lot of the time, their competitions they only give you certain points. You know, the provider has. The provider in this case.
Well, most of these frameworks
So
are
did you
like
look at it?
Video
we've done all the way through.
images or the coloring is not reliable.
I think it's more indicative.
The colors might not
Oh, you think so?
be.
Hey, yeah, this is I'm sorry, it's 2009. It is so future forward compatible. I keep on installing stuff.
I think we want to sort it by pair, and then, basically.
Isn't there something called invalidate forces?
Invalidate forces it, yeah. Always, yeah, most frameworks. What I'm wondering is, it might just be something off the route. So it could be that you have to get to the surface. This is an activity. I think it's coming back to me now. This is an activity that we actually want is the render surface, and then we override the onboard render surface. That would be.
That's
Render surface.
So render surface is just like a.
Who's the highest?
Is that the canvas?
Yeah, so it's going to be like a canvas. Where is a canvas?
I think there is a canvas.
You're not beating 99.5, so.
I'm so close.
Have an event.
You're beating 99.5, we're not winning the competition.
God,
There might be an event on.
Okay. It's over here.
I'm going to stop now, but
Okay.
it's probably something off. It's probably not on the activity at all.
so it's probably not on.
On the activity, it'll be one level down. I remember seeing an example, and then I tried to make this sample as small and as compact as possible as well, because it's missing. But it's amazing it came up on the glass.
Listen, since there's no buttons, you know, it doesn't do any good. But I've not been able to find anything that doesn't actually run. There's buttons that you can't hit,
Right.
you know, but.
So how do I check basically? Yeah, so I just want to check to see if there's
There is no concept of null.
Yeah, that's what I.
Well,
It's
okay.
like the letter, like how long
So
we have to
can I
look
say
at
like,
letter
okay,
to get.
can I go?
No, that's
not.
Now, yeah, you do the not equals, but empty string, but.
Okay.
You're talking about.
Yeah,
So,
What's the question?
oh,
That's
what
that is. That's the sequel.
Oh, I'm trying to create a where you see something, and then it's going to ask you yes or no, and then you just go like this. And that takes you through a flowchart.
Oh, okay.
Because it's got a gyro.
Oh, no.
But you're going to be talking about but it's going to be tunable so that I don't know, but it's it could be relatively imperceptible. But then if you're in a noisy environment like driving or something, then you could maybe make a little more gross.
But the old people who are like,
Well, that's another thing itself. Because well,
I just can't wait until I get glasses that look normal, because I wore glasses for 20 years and then got LASIK last year.
oh yeah.
And then I'm like, oh my god, now I need to wear glasses for the rest of my life so they can have a screen.
Yeah. Well, actually, there are prototypes over in Taiwan where this is actually built into this. Yeah. So.
Beautiful pass.
Okay. We're all going to try it out. It probably works better with your glasses because it's at Hobolinks at about 8 feet. So. Okay, so can you read the smallest print?
I think it's got big words though, as you add more.
How do I get the TV back?
And then
Yeah,
actually
because
this,
you'll
just
need
TV
older.
the,
I would think.
tell me when it says bubble.
Or something.
it was now it's gone.
Okay.
I mean, if you just, if it was just adding.
Right now?
When I added siblings,
That's F sharp.
the rate went down.
So
So
I-
decision
well,
tree,
that's
as
F
opposed
sharp.
to having
That's why I
siblings
came
out.
here tonight was to do this.
Maybe you need to,
Let's do,
get sit, I mean, if
that's just
you
my
go back
idea,
to
so
like
it's
siblings
like-
over
One
2.5 or something like that.
Okay,
So, because otherwise you're making the tree too.
how old is Barack Obama?
So, how do I get the monitor
I
back?
may confuse it because it's here in the 20s.
Anton, where's the remote control from the?
Just turn the
Let's see. See, now we're
Yeah, it's a
actually-
power saving feature.
no,
So,
moving it.
did I hear 83%?
83.5.
83.5, so assuming you went in, you would actually be in the top 50 with that. That's good, although you're going to be running against a slightly different
Yeah,
test
it's,
set.
it's
Because they hide the
you
test
wouldn't
set
use
from you.
it for, you can do mobile websites very easily where they're narrow.
What's your cheat?
And if it's not mobile optimized, then you can still like zoom in.
That's absolutely
Get
crazy.
a bit of information.
I'm
on,
just
like, a
because
frame or
I
something
know
if you need it.
no F sharp, and it's like I got 80-something%.
Cool, what's your score?
Yeah, go back the other way.
80.06.
Nice, I think that gives you top 100 or 200.
See, so it's like back in a browser.
Yeah, that gives you,
And if
you're in the
just
top
want to
200
I
with that.
think
That's pretty cool.
I don't really always see that.
So there's machine learning students who are doing
Yeah, you
work.
see, it seems like a timeline.
It's pretty crazy, isn't it?
And then what you do is,
And the history is you cannot delete the history.
yes, you can. Yeah, there's all kinds of things. And what you do is you go to your Gmail account and you pair it with your Gmail account using the QR code. And then you go into your Gmail account and then there's a list of things. You say CNN, yes. L, no. You know, you basically say
81%.
and then you can prioritize. You say, I only want the most
The
important
videos,
emails.
like, can you watch the videos?
Oh,
Or
yeah.
how long? Is that the
Well, if you watch it, yeah, if you're watching a video, that lasts an hour or two max. But if you're just using it to like, you know, answer emails and things like that, it can last 6 or 7 hours. But this is just a prototype. I'm sure there's going to be more.
What about the GPS? Like, if you wanna,
GPS is based on, the GPS display and interaction. I mean, it works way better. And it's very simple. Because you're driving along, it's a half a second to look up as opposed to look on something on your dash.
So how long the battery lasts? Because it's using the battery for the GPS.
No, the GPS is still in the phone, and this is Bluetooth too.
Oh, okay. So whatever is supposed to be on the screen is
Yeah, so there's no SIM chip in here.
So let's go for another 5 minutes. I've just put up these features might be interesting too. I think so. One of the guys in London got about 84–85%, and he used the fare. He used a metric on the fare over like 100 or something. So I'm just picking that out of the sky. You want to have a search for that, but if you have a go with that, we'll do 5 more minutes, and then I'm going to wrap this up.
Well, I'm sorry that I came here not interested in machine learning. I'm just trying to get my environment set up.
That's awesome. That was great. I've never seen you give a class before. That's
Yeah.
it's all about the social media things.
Is it?
The tasks
Oh,
are
yeah.
just like
Although it probably wouldn't be, you wouldn't probably do any number crunching out here. But there's a local guy named Charlie Green who does natural language processing / geotagging. And so I've been talking to him about having a conversation with a kind of a semantic-based GIS application. So I'm going to work in that school, and then I'm going to and it maps that to lower level interactions.
if you've got vacation.
Yeah, but it has to have that kind of, you have to be able to draw Venn diagrams around what's work, so all the spots that are work-like, and then predict whether it's work-like even if you've not seen that spot before. It's kind of, don't bother me now, I'm working. Even if someplace you've never been before.
That's where I want something like cheap machine learning algorithms. I just want to, in effect, the thing is not to think of it as absolute.
Yeah.
It's to think of it, I've got 80% belief that it's work. And I've only got 50% on it being home, so I'm going to...
I was in the first graduate program in computational linguistics, but it was before they did machine learning, so I did all the linguistic theory, and then wrote all my rules by hand, and I realized that was not going to work. And then I transferred.
You want you just want to let it computer work.
Well, now I think there's, I hear, people, the graduate students in computational linguistics I talk to now, they do say that there's a bit of a swing back for features.
That's why it's so long on it.
So it's useful to have, for natural language, it's useful to have a linguist to figure out what the set of features are in machine learning.
The thing with machine learning is they're not always treated like a black box. Put it in a black box, crap out, basically. Give it some guidance. And check the ranges. So the other, I haven't done the final push on is how large is your data set. One of the worst ones is use a neural network training and it's 20 data It's not no statistical algorithm.
I didn't really take advantage of it, but while I was in my coupling program, I was sitting in Jeff Hibbs' seminar at CMU. Geffen and Turetsky. McClellan was a cognitive psychologist who used this stuff to model, and he would do some semantic priming. He really wasn't trying to do the super efficient, super effective predictive stuff. He was trying to build some models. It didn't work very well. It didn't work very well in exactly the same way that humans try, which is really kind of fascinating.
That's good for games, actually.
Yeah.
You don't want them to teach you. You just want them to you know, I met Jeff in this.
Yeah, it's been 20 years, but he's delightful.
I saw him 5 years ago.
Is he still in Toronto?
Yeah. His deep belief networks are huge. We're going to do a prediction system for Bitcoin with deep belief networks in London. So it could be quite profitable.
Prediction for what?
Bitcoin prices. Exchange.
Like a stock exchange?
Yeah, and deep belief networks are pretty much got the best prediction rate.
There's a loop. This loop of 1 to 400. I could just stick a little timer in there and pause, do a little bit of logic, and control the animation.
Well, you could, it's not.
That's a bad idea, but
it's a start. Yeah, because you're plugging in your life.
Or they could put it on a thread or something.
I don't know. Yeah, I don't know enough about this particular one because most of my work I did this and I didn't want to.
Usually the way they do it is to
yeah, that's what I do on the. But I do it on the timer on the JavaScript. I call back on a timer. So you could do a timer on it.
Yeah. That's the one I just.
I literally think it's just 2 or 3 down on the hierarchy. So off activity.
So I should go find what object do I need to? I'm sorry, I'm very rusty on this.
I would just go and search samples on.
Okay. What would I search on?
Or wait till like Wednesday.
Okay. But I've searched on F# and on
We're like isolating down to one person.
Look for C#.
Okay, well what's the C# equivalent to on draw?
So it would be something like on paint.
On paint. Okay.
That's what it is in waiting for. Okay, so anybody want to come up and show us their predictor? James, could you come up and tell us about your classifier?
Yeah,
well, I don't remember what this was. It's a little
okay, but I go there and it's not.
Could you bring your computer down and plug it in?
Okay, but I'm not like in my IntelliSense here.
No pressure. So whoever does this gets to speak at the next event. Here's your new speaker. Hoping for a lot here, but it just won't. Hey,
done Android programming before? You override the on draw.
All right.
84%.
And then something calls it.
That's pretty awesome.
We're hedging the bets here.
An
So
on draw.
what we looked at is we looked at passengers that have
But we're not sure.
one sibling or more, and also have over 2 parents, or I guess, well, parents and grandparents.
Yeah.
I gotta work on it.
A big family.
That actually had a cabin listed. We noticed that if they had a cabin listed, that made a difference. And then passenger tickets is kind of random. I was looking at the data and looking at passenger tickets, and I had some assumption that maybe they drew a lottery based on tickets or something like that. So we were looking at passenger tickets in between, 1,100 and 1,200. So we're really hedging the bets here. I mean, we're looking at a pretty detailed set. So that's what we did to.
That's awesome.
Yeah.
There you go. Well, yeah, I think that.
Chief data scientist.
I think that gets you in the top 50 of the competition. So, That's pretty good for an hour and a half and probably 10 minutes work on prediction.
I had a little help.
So as you can see, you can get a long way with decision trees. If you were to just, in effect, I'll give you a link to it, change where it says create tree to create random forest, you'll be able to try it out and see if you get better prediction. Typically you will, and it would more than likely work better against a larger set of data. Cool. Thanks very much.
Thank you.
So I'll just take that back, and I'm just going to give you a little bit of an outro before we go down the pub. Well, that's the edition of where I'm from. So let's see if I get the slides back up. Okay, so I'm quickly going to do some thanks. Matthias, who you've already met, helped me out with these samples and others, and it's actually helping me out in the progressive F-sharp tutorials in New York. So big thanks to him. Thomas and Gustavo did the F-sharp data library. Type providers, which I hope you'll see are utterly awesome, by the F-sharp team. And it's not just, as we've seen before, it's not just JavaScript. I'm going to give you a quick demo of something a bit mind-boggling in a sec with type providers. The Machine Learning in Action book with code samples from Manning is pretty good. It's got a nice focus. I'm from the dev side. It's nice to see machine learning algorithms with code. There's some really huge books, one by my supervisor, Chris Bishop, it's almost entirely impenetrable without a single code sample, not so hot. But there are more and more books that are making this topic more available to us devs. And Kaggle have given us some great data sets to play with. I think the Titanic data set's a lot of fun. Who lives, who dies. This is the machine learning job trend in the UK. Wage rates are looking good as well. I'm actually having a joint meetup between the F-sharp meetup and Women in Data. So we're going to have a huge meetup that way. So maybe you guys, you're looking a bit female low. You should be reaching out to the data scientists and bringing them in. But it's definitely on the up, the machine learning side of things. Let's do a quick gratuitous sample. Some of you will have seen this already. So if we go to FunScript, you can do this also. FunScript has a type provider to the TypeScript language and also other data sets, okay, which means that you can in effect have jQuery inside of your language. WebSharper does the same thing as well, so FunScript's more for like one-page, simple, tiny apps, and WebSharper's kind of your supported thing for when you want to move to a commercial app, but here it is. So here we get the types for jQuery and for high charts, for drawing charts. The World Bank, right? Types to World Bank. This has got the data for these countries. Again, there's been no code generation step, so it actually gets the stuff live off the World Bank data. And we've got some asynchronous stuff here, and it calls the high charts library with typed data, and then it generates a JavaScript web page you can just slap on your web server. Don't even need to run ASP.NET, which is pretty amazing. And we can see that running if I can find the right button, maybe it's the one that says Open Sample. And you know, you can do this on your own machine. So we picked a few things. There's the chart. So that was like 40 lines of code. Hey, that's one to impress your boss with, isn't it? So, I mean, the idea with the fun scripts is sort of like just really simple little programs, maybe getting a little dashboard up. Nothing too complicated. But that's a pretty good example of type provider. So we've connected to a different programming language. So I'll just quickly show you that in action with Super Mario. So we create TypeScript to, in effect, jQuery, connections to jQuery, and now I've got context as a 2D renderer. So I've got here, that's IntelliSense over jQuery. Yeah? Yeah, that was at last, we managed to do it. Yeah, winning. And then, yeah, that's just so awesome, isn't it? And here I've got like the keyboard events, and I've got like IntelliSense over that. But this is all going to get compiled to JavaScript. Now, this is Super Mario in just a simple running around in 40 lines of code, including comments, not many comments.
Can you debug it?
No. There is no enterprise unit test.
Yeah, it's called alert. So no, the F# 3.1, which just came out, which is in Visual Studio 2013, has the compiler stuff that you need in theory to add debugging support into Web Sharper and FunScript. So we just got to wait for the guys to sort that out. So this is a F# record. So in effect, this would be like a 50-line C# class. So this is a property for X, Y, and it's an immutable class. So what we can do is we can pass in to our jump function a Mario, right? And it's going to return a Mario. So in effect, what we just keep doing is we change the Mario. So the controls come in, where for jumping, if the up control, Y, is pointing up, it's a jump. So if we're pointing up and we're not already jumping, then we create a new Mario with the velocity on the Y at 5, and we're done. Else we return Mario as he was. For gravity, if we're not on the ground, then we subtract 0.1 from Mario's upward velocity, right? So he will bounce up. If he is, otherwise he stays on the ground. The physics, we get and make a new Mario with the updated X and Y and so on. Then we can compose that all together. We have a step function, so for each frame of the game, we pass in the direction, the X and Y, and the current Mario. And it takes Mario, applies the physics, which then creates a new Mario with the physics applied. We ask it to walk in that particular direction, apply the gravity and a jump. That's pretty sweet, huh? That's the whole logic, and it's quite readable, I think. So it's very similar to what we've been doing today with the chaining of functions together. Rendering blue sky, green, have to trust me on this. Red, green, blue, right? Green's high here. And then we just change the particular Mario based on it, the view. And if I run that, let me just check on. Try not to have demo fail. What happens now is it compiles that F# code into JavaScript. There's no ASP, nothing like that, and drops it in the browser. Mario.
Does it come with sound effects then?
We'll do one with sound effects. So that is Mario. Let's crank up the volume. Just check out. So the runner, you can only have one runner running at a time. So here's another one I prepared earlier, Pac-Man. Quite irritating.
Awesome.
You can you can. I've got this online if you want to play it. It runs on pretty much all of the mobile and web browser things. The only downside is on the mobile phone it only seems to work on my BlackBerry because the controls. You can see it, but you can only actually play it on a BlackBerry because you need keys. And until I've worked out how I'm going to do touch. So I've done a version on Windows Phone where you rotate, so it's like the marble game, but it's actually really hard. So I think probably just touching. We've got another one on Android. I can show you if anyone wants to come and have a look later, where you flick Pac-Man to change direction, and that actually works reasonably well. Just for some inspiration. This is very inspirational to me anyway. So yeah, the twisting thing. Anyway, moving on. So I think I digressed a little bit from where we were supposed to be. We're pretty much at the end of the thing, and I'll do questions and say. So what next? More machine learning information. If you go to fsharp.org, the F-Sharp Foundation, which has got information about building F-Sharp across different platforms, Mac, Linux. Also sections on F-Sharp in finance, F-Sharp for gaming, F-Sharp for machine learning. You can find out a load of different libraries and algorithms available, different tools. So we can go a lot further than we've gone today. I don't have to list a huge number of links for you. The random forest, tinyurl.com random forests, will take you to Mateus's implementation with examples and explanation of how it works. The other one I'm selling today, I'm selling two things today. Progressive F-Sharp tutorials, like the day after tomorrow in New York. For 2 days, get to meet Miguel, who is behind Mono, Don, who wrote F-Sharp, me, Thomas Petricek, all sorts of random people, for a lot of fun. There's going to be a lot going on there. Machine learning, we're going to do Pac-Man AIs. Don's going to teach people how to write their own compiler and edit the F-Sharp compiler. Lots of excitement. If you can't make that, why not come and see me in London in October? We've already got about 60 people signed up for the end of October one, which is more than the equivalent .NET event, unsurprisingly. So it's going to be the biggest one. I'm working on a book called F-Sharp Deep Dives, and we've got some machine learning, social gaming sections on that. You can get that in Meet from Manning at the moment. that's what floats your boat. There's stuff on finance as well. And if all of that gaming stuff's got you in the mood, we're running a game jam in New York on Friday. So do a bunk, throw a sickie, come up to New York, and you can write a game in a day with me. Cool. That's all. So any questions? Where's the pub? Okay, thanks very much.
Alright, I have a question about decision forest. Can you give inputs that aren't, just binary data like?
Yeah. For the decision trees, you can give. I did mention you can give it like the embarkation point, and it will just work it out.
How about like a value, like fair?
So yeah, you could give it a pair, you could give it anything you want. Obviously, if you were to say give it like the age, it wouldn't do very well because that data is too sparse, which is why we narrowed it down to child and not child. But remember, if we did that function where we had child, adult, over 50, so you could give it that function, and it would happily work off that.
So it has to be some sort of, it can't be continuous data.
You could give it, it wouldn't work.
It wouldn't work.
Yeah. It wouldn't give good prediction unless your data set was really huge. You would get overfitting at that point. Cool.
I have 2 questions. The Pac-Man, was that made in HTML5 or F#?
It was made in both. It was F#.
Originally coded in F#, and converted to HTML5.
It was I'm written in F#. I'm using the type provider to call onto the HTML canvas, and then it gets compiled out instead to .NET. Gets compiled out to JavaScript.
Okay, and what about the slide? How can I get the slide? Is it like online, like Meetup?
Yeah, it's. I'll post it to Anton, but it's actually on my blog. So if you go to Trelford.com, follow the link to the blog, and it's about. I'm a bit too active on my blog. It's about 10 blogs back, but it is on there honestly.